Well, hello there. My name's Mike, and welcome to my workshop preview, Essential GDB and Linux System Tools. This is a day-long workshop that's going to be held in conjunction with C++ Online. So let's go ahead and dive in and check out some of the details here. So what is this workshop? Well, again, this is a workshop where you're going to be learning GDB as an example debugger, as well as the essential Linux system tools for debugging and just building better software. And this is going to be really increasingly important to have these skills on how to debug in this age of AI generated code, or just in general working with massive code bases. So whether you're an expert or junior developer, these skills can be useful for you. So let me go ahead and move out of the way so you can see all the details here on when the workshop is hosted, Friday, April 17th, 2026. And again, feel free to reach out to me in my contact information if this is otherwise something of interest later on. But this is the day that you're going to want to join us in conjunction with the C++ online conference. All right, so a little bit more about me. I am a teacher, so you can read a little bit about that. I also do industry work as well, but I really love teaching. So this is my passion. You get to join me for a day here and learn some essential skills. So with that said, I am a frequent conference speaker, so you can check out some of my other talks if you're interested, including other little short YouTube videos, again, if you're just in love with this topic like I am. So what are you going to learn here? Well, let's go ahead and I'll let you pause if you want to read the abstract, but let's just go ahead and dive in. Let's see a little bit more about what we're going to be learning in this workshop. In fact, I've structured this in several different parts. So again, if you're working with me throughout the day, we're going to look at things and build up slowly from just learning the essentials of what is a bug, what are some strategies for bugs, to the basics of using GDB, to some more advanced features. And that's what I want to give you a little bit of a taste of today so that you can see and understand what this workshop is about. And again, this is a very hands-on workshop, you're going to find out. So you're going to be doing stuff as I do it to make sure that if you're dedicating the time, this block of time to do the workshop, you're going to leave with some activities, hearing them, seeing me do them, and then you yourself practicing them as well. So at the very start of my workshop, I'm going to go ahead and pose you a question during our introduction to debugging. And that is, well, why are we here? Part of this is being able to understand what our goals are and basically be able to understand why this is important. And I'll go ahead and give you a hint as to why this is important. I mean, can you answer this question? Maybe just think about it yourself. How much time do you think you spend debugging your program? Do you spend a lot of your time writing code? Maybe less and less even these days. So if you think about this, and I think this number is actually going to grow over time, it's that various estimates, depending on what empirical studies you look at, say that we spend at least 35%, maybe 50%. I've seen as high as 75%. Maybe you've been like me and spent 2 weeks on a single bug before, trying to get it fixed without writing any other code. We spend a lot of time debugging. So we need to be able to understand how that works, this process of finding errors fast and then being able to use our tools to, well, help us find errors fast and also fix them and maybe even test them to make sure that they don't come back. So this is the basic answer here. And what I'm going to be showing you is various tools. We'll start off with GDB here in a moment so you can get a taste of that, which are kind of like your get out of jail cards. Now I'll use the analogy from Monopoly, which is a board game where you sort of go around the board here. And the basic idea is if you land on one of the bad squares, you go to jail for a little bit. But part of the fun of the game is you can get one of these get out of free jail cards. So you don't have to be in jail. You can go around and collect more money in the case of Monopoly, or points, or however you want to think about it here. So learning how to use a debugger, or just the debugger and maybe other tools, including your compiler, it's like having a bunch of these get out of jail cards. And this is what we want to do in this workshop, is try to understand what tools we have, where they might be beneficial in various situations, how we can just turn them on automatically so we don't have to think about it, and integrate some of these tools in our workflow. We want to integrate them in a way that makes sense so that they're not overwhelming. So that's why we'll start with the foundations. So speaking of foundations, let's go ahead and take a look at what some of those foundations are that we'll be learning here. All right, so let's actually learn something, even in this teaser video, about how to get started with a debugger like GDB. And I'll have a bunch of examples that'll be provided if you sign up for the workshop so that you can go through these exercises again as I go through them. So anyways, let's go ahead and get started. And we're going to be using GDB, which is the GNU debugger, which is freely available. So you're going to find it on Linux relatively easy. You can also run it on Windows or in Windows subsystem for Linux. And again, it's just a great debugger. And in general, if you're not able to follow along with GDB, you could use LLDB, but the commands are going to be a little bit different, but the principle is often the same. So anyways, we're going to be using GDB here for these lessons here. And there's a variety of different resources that can help you set this up. Or again, I will provide you during the workshop with a virtual machine so that you have all these exercises otherwise. And if you're just running on Mac and want to follow along in the Linux environment, you can do that as well. So I'll have all that set up for you. And we can also get you set up with VS Code. But I do want to emphasize I'm going to be showing you everything on the terminal because I want to show you the bare basics so you know how something works. And then you're not tied to some extension because those extensions might change, the tool might change. So I want to show you the foundations, the sort of first principles that will, again, apply everywhere. So this workshop and the skills that you learn can be useful for, many years to come. So anyways, I'll show you some brief examples on different tools on how to get started, and then I'll show you on the terminal. And again, if you're just like, hey, Mike, this is way too much for me, onlinegdb.com is a great way to just follow along with the exercises as well, so you don't get stuck with the setup. And again, you can follow along in this workshop without any problems. So let me go ahead and teach you a little bit of GDB now and how this works here with just a few different commands. So let's just go ahead and dive in here. And I'll show you just a few of the basics that are listed here. And then I have slides to kind of walk us through and help us understand exactly what we've done here. But as mentioned, here is a bunch of samples. I'm going to make these a little bit larger for you so that you're following along on your screen here. Let's see here if we can make that a little bigger, so you don't have to strain your eyes too much here. Let's do biggest font. There we go. And I'll go ahead and move into part 2. You can see that there's a bunch of different parts for which I'll provide you the files, and there'll be a bunch of different exercises here. And I'll use a mix of something like C, or in some cases C++ if I want to show some object-oriented features, but it doesn't really matter so much. You can even debug D code or Rust code or other languages, Python and stuff, whatever GDB supports. Again, this can work on any of those languages here. So let's just go ahead and split my window here, and we'll look at this example here with an array here. So I've got a C++ standard array here. I'm going to try to access some of the indices and maybe run through a few of the commands here, just so we can get a feel of what's going on. And if you've never used GDB before, then it's relatively easy, but we do need to make sure that we do something very important here. So I've got my program at the top here, and you'll notice I have instructions on how to compile this particular program. This program needs at least C++ 17 here. So I'll go ahead and type this out, G++, whatever standard you think here. I'm usually using 23 these days. Let's be on the cutting edge. And let's go ahead and output the program here. But importantly, if I want to compile with debugging, I need to use -G to add debugging symbols. So I'll use -G here and go ahead and compile. And it looks like overall this program's doing a okay job. I mean, there are there's quite a bit of warnings here. And later on in our workshop, we'll talk about a few of these things, especially the specific C++ things here, where we might not want to ignore some of these values here that we're returning. But again, this is just going to be a basic example here. So anyways, our program's compiled. It doesn't really do much interesting stuff, but it'll serve as a good test bed for us to just get started here. Now, again, what was important about compiling using -G here to make sure that we compile with debugging symbols, things like line information, file information, symbol names, and so on, that's compiled with our executable so that I can identify this symbol for me, the programmer, and have that additional information. Now, there's some other little caveats here. If you want to add power, you can use -GDB here. So that's the GDB broken out here, or -G3 to get more debug information. So again, I'd invite you to do that through the training, and we'll do so where relevant. Now, again, the first thing that I'm going to do here is let's close up that source here, and let's run with GDB here. Let's do GDB. I'll run my executable through the tool. And again, I can now run this program within my GDB here. Now, if I run it and it exits normally and there's no bugs, or at least nothing detectable, no seg faults or anything, that's good news here. And I can do some things like maybe list out some of the symbols here so we can actually get some insight into our code. Again, that could be also a useful way to just jump to code. And I can kind of explore this way. But this isn't as fun here. So immediately what I will introduce you to is the text user interface that's built in GDB. And then I can go ahead and do that same example where I list main. And now I have a window of code at the top of my screen, and then I can enter the commands at the bottom. And this is really, really cool. So now I can focus on my source if I want and use up and down to get a preview of what's going on, or I can focus back on my command window. And I'll teach you all of these shortcuts as we go along, and you can learn them here. But let's go ahead and just, again, run our program here. And that's immediately going to just execute our program, start to finish. So that wasn't very useful for us to gather some insights into the behavior of this program. So let's instead use start, and that'll bring us to the first line that we're going to execute. So we'll see in the prompt here that there is a temporary breakpoint for main. That gives us an insight into what function we're in. And we're about to execute line number 27, meaning I can try printing out my array, for instance. And again, I can confirm a behavior in C++ that this array is just filled with garbage. I can print out the actual elements here. But if I move forward by using next to execute the next line of code here, and then enter, and then I again repeat that command, this time using Control P to save myself a little bit of time, then I'll see that that 0th index indeed has been set to 7. And we can go ahead and hit next again. And then I can print out, again, my array and see that we've updated the value here. Well, that's pretty cool here. That's pretty neat that we can do that. And again, I can go through and see some of these exercises. So I could go ahead and see what's in the front, back size, max size of this array is, and gather some of these properties. Now, what was interesting is when I compiled this, you saw that huge list of errors that I was getting, or warnings rather, that I wasn't using the return value here. In fact, these really aren't that useful to have. Why aren't they that useful? Well, I can actually just from within GDB do a little bit of introspection here. And I can say, what is the front element of my array? And again, if we look at the data that we have, and then I execute this call for this function, I can get 9 back there. Let's go ahead and do print my array. And let's go ahead and see what the size is. If you don't remember or you need the context for whatever reason, it is, in fact, 5. In fact, maybe I don't even remember what the type of the array is. Let's print out the type here with ptype. My array, and get a little bit of information here. And we can see towards the top of the printout here, stood array with 5 elements. And it even gives me some of the structure for this array type here with fill and swap and the begin iterator and so on and so forth. So already we can see a few cool different things that we can do in GDB here that can also save us from littering our code and getting warnings that didn't even matter anyways on information throughout our execution here. Okay, so we're really interested in this array. It's a little bit of a boring example though, so let's kind of accelerate just a little bit further here and do some other live coding. So what I'm going to go ahead and do is switch our example. We'll use this one here, GDB. And I'm going to go ahead and compile it once again. And we'll just call it prog. That's usually my convention for outputting my program. We'll compile it. We don't know what this program's going to do. Maybe I'll just run it here. And it gives us a segmentation fault. Okay, that's interesting. Now we actually want to start exercising our skills in debugging to take care of what this issue is. All right, so let's go ahead and dive in to GDB again. And this time I'm going to launch with that text user interface, our program that we wanted to execute. I'll hit enter to get rid of the messages that were there and start at my prompt again with start here. And again, the easiest thing to do is perhaps just continue my execution and see where we ran into that segmentation fault, which segmentations aren't bad things necessarily, segmentation faults. They are doing a job to protect our system. And our screen gets a little bit wonky here because I'm outputting to the same terminal window. We'll have to fix that in the full day workshop. But for now, I'm just going to hit Control L to clear my screen. And what are we doing here? Well, it looks like this is where my crash is. It says program received signal segmentation fault here. And clearly, if you study this code, if you've done a little bit of systems programming, although we'll review some of these things here, dereferencing a null pointer is not good behavior, right? There's no memory here. There's nothing, no value to get or to set to 10 here. Now, how did I get there is kind of the interesting part of the story. So I can look at the backtrace, for instance, and see that I was in the main function, then I called into helper, and then ultimately other helper. And this particular variable is interesting enough that maybe I'll want to watch this variable and see when it changes. Or I know other helper is also a place where I might run into trouble, so I can add a breakpoint in here. So let's add a breakpoint, and I'll hit tab to autocomplete and find my symbol for other helper. And you'll notice this B symbol shows up here for a breakpoint. So now if I restart my program by just simply typing run, start from the beginning, so it's just going to execute all the way through until it hits a breakpoint, and we'll get back to this position here. And then again, I can do my sort of introspection here, where I do next, and then I perhaps do something like a print command, which we learned here, so I can print out P, I can print out the address of P, and so on. But clearly when I print out P, I see that it's pointing, or it is a pointer type storing a 00 value. So if I try to print out that value, right, this is the same thing that's going to happen here, and ultimately our program will crash. Now, I'll show you something that's not exactly the right thing to do, but it is a cool thing that you can do. And we'll go ahead and just set the variable here, P equal to, well, let's actually malloc that data here, and we'll do the size of an int here. And then now if I print out P here, I'll type out print P, we see that there is some memory here. So we can actually move forward now. So that's kind of cool. That actually maybe helps me test some hypothesis, maybe if I'm just doing a little sandbox here. And then I can kind of play around with GDB here a little bit and continue forward in my program. Let's keep going here. And eventually, well, I don't want to give the surprise away from my exercise. There are more bugs in this program. Always more bugs here. So the other thing that I want to go ahead and just show you here is some other ways to monitor interesting events that are going on. And we can do something just like display. I've got this object here, lowercase o1, and we can then see that this is some sort of struct here. And display will basically tell me every time I do some change to this variable, or basically every step in my program, it'll update what these values are. But probably even better, I can do a watch here and watch every time that object1 is modified with a read or a write. And I can actually do watches on specific addresses, all sorts of interesting stuff here to catch interesting bugs. Now let's go ahead and see, for instance, if I do my info on my watch points or info display, then I can go ahead and see what types of things that I am interested in monitoring here. So I've got my watch point and my display. Let's delete one here, which is this display here, because that's going to basically cause a little bit of noise here. Oops, and if I make a mistake here, I can either do help display to search my system here, or I can just undisplay and use the right command here. Okay, so info display, I've got nothing, and info my watch points, we've got one here. So let me just go ahead and hit next just to show you what happens here. Is I modified in line 31 the value of the first field to 7, so we can see that that changed here. And we can see between the old value and the new value. And again, if you have some object you're interested in monitoring, whether it's some like global state or something more local, then that can be very, very helpful. Okay, so the line that I'm about to execute is 32. Go ahead and make your prediction what output we're going to hit if I do N for short or type out the full command next. Go ahead and hit enter. And again, we can see this printout here. So there's a wealth of commands here that I want to be able to teach you during this workshop to save you time. I mean, there's even stuff like, what if I don't want to go through all this loop here and I can advance forward, or maybe I could set a conditional breakpoint. So there's just a wealth of things in GDB that I want to show you. Now, very briefly, I want to talk about some of the other tools that you're going to learn beyond GDB, because there's an interesting world here beyond GDB as well, as far as debugging and just gathering system information. So beyond the GDB commands, we want to actually learn what's going on behind the scenes. Again, this will give you a little bit of intuition as not only what these tools can do, but how they're working. So we're going to understand things like how information is stored in the actual executable for the debug information. And we're going to talk about debug and release builds. And what if we want to strip out that information from the debug binaries, for instance? So again, you can think about this, but again, these are super, super useful things for either your continuous deployment, being able to strip out the debug symbols, maybe store them if there's something that happens. Maybe you have a product released in the wild and you want to understand when some users version of their code breaks, that you can take that version of code, add in the debug symbols that you've stripped out, and then you can perform some debugging and help them. Or maybe just when you're deploying your software to some embedded device that's not even on your machine, you want to inject the debugging symbol. So we're going to talk about all those different things with debuggers that you can do, and again, the ecosystem around them. And beyond that, there's tons of useful tools like strace and ltrace, and I want to show you how to use your compiler, how to do various static analysis, things that, again, are just going to make your life easier for finding bugs. Even things like cppcheck, which I think are quite popular in the community, are going to be very useful tools to know and integrate into your ecosystem here. So with that said, folks, we'll go ahead and start wrapping up. So thanks for joining me for this brief teaser into my workshop. I think we're going to have a really great crew on April 17th as part of C++ Online 2026 to learn about these essential skills, debugging, and the tools and ecosystem around debuggers to help you write better software and understand how software works. And with that said, folks, thanks for your time and attention. I look forward to hopefully seeing you in a workshop very, very soon. Bye for now.
Okay, so that was the workshop preview from Mike Shah. I hope that was informative and gave you an understanding of what the workshop is about.